everyone, welcome back to my YouTube channel. I am Ranjitha.G, currently studying in Sri Venkateshwara College of Engineering. I am from Computer Science and Engineering branch. Today's topic is stationary distribution of regular Markov chain and absorbing states. Introduction to Markov chains. Markov chains are mathematical systems that undergo transitions from one state to another on a state space. They are defined by their transition probabilities, which dictate the likelihood of moving from one state to another. Understanding Markov chains is crucial for various stochastic processes in fields economics, genetics, and computer. Markov chains are used in mathematics. It is the system that undergoes transition from one state to another state while solving the issues. There are types of Markov chains. Markov chains can be classified as regular, absorbing, and irreducible based on their properties. There are three types of Markov chains known as regular, absorbing, and irreducible based on their properties. A regular Markov chain has a unique stationary distribution that is approached as a number of steps goes to infinity. A regular Markov chain can be described as it is a unique stationary distribution that is approached as a number of steps goes to infinity. Absorbing Markov chains contains at least one absorbing state where once entered and it cannot leave. Regular Markov chains. A regular Markov chains is one where it is possible to reach any state from other state. It is a finite number of transition. Regular Markov chain can be defined as it is the one where it is possible to reach any state from other state and it has infinite number of transitions. This property ensures that the transition matrix raised to a large power converges to a matrix where all rows are identical to each other. Stationary distribution definition. The stationary distribution of a Markov chain is a probability distribution that remains unchanged as the system evolves. The stationary distribution can be defined as it is a Markov chain of a probability distribution. It remains unchanged as the system evolves. Mathematically, it satisfies the equation pi p equals to pi, where pi is the stationary distribution and P is the transition matrix in the stationary distribution definition. The distribution provides insights into the long proportion of the time the system spends in the state. Finding the stationary distribution. To find the stationary distribution, one can solve a system of linear equations derived from the transition matrix. The equation typically include the normalization condition that the sum of probabilities in the distribution equals 1. To find the stationary distribution, we can solve a system of linear equation that is derived from the transition matrix. It makes it easy to find the stationary distribution of a Markov chain. Properties of stationary distribution. The stationary distribution is unique for regular Markov chain and is independent of the initial state. If the Markov chain is irreducible and aperiodic, the stationary distribution is guaranteed to exist. The stationary distribution is unique for regular Markov chains and it is independent of the initial state. So the properties of stationary distributions are it is unique for regular Markov chains and is independent of the initial state. If the Markov chain is irreducible and aperiodic, then the distribution is guaranteed to be executed. The convergence of the stationary distribution is regardless of the initial distribution of chain. Absorbing Markov chains. Absorbing Markov chains have at least one state that once entered cannot be left, known as an absorbing state. The presence of absorbing states alters the behavior of the Markov chain significantly as the certain states can trap the process. For observing the Markov chains, we have at least one state that which is already once entered and cannot be left, known as an absorbing state. The presence of absorbing states alters the behavior of the Markov chain significantly as certain states can trap the process. Transition matrix for absorbing state. The transition matrix of an absorbing Markov chains can be partitioned into submatrices representing the transient and absorbing states. The structure of the matrix helps derive formula for expected absorption times and the probabilities of absorption into particular state. The transition for absorbing state is can be partitioned into subpractices and representing transient and absorbing states. Applications of Markov chains. Markov chains can be widely used in various fields including economics for modeling market, trends and decision processes. In computer science, the applications of Markov chains they are integral in algorithm for web page ranking and the natural language processing. Conclusion. Understanding the stationary distribution and observing state is essential for analyzing the long term behavior of Markov chains. So, the conclusion is about the understanding the stationary distribution and observing state is essential for analyzing the issues or behavior of a Markov chains. Regular and observing chains offer diverse applications across many disciplines, highlighting their importance in probabilities modeling. The exploration into advanced topics like Markov models can provide deeper into complex systems and it feels easy to free to adjust the content based on your issues. Thank you for watching my video.